So we're going to look at how to do proofs in maths. Okay, so in a proof, what we're trying to do is take something we know and add something else we know and prove something new. And that's the whole point of proofs. Okay, so we're talking about proofs, and we know we're talking about proofs because it says prove that the interior angle sum of a triangle is 180 degrees. Interior, that means inside, and sum, that means add them all up. Okay, so in this sentence we have in the first line of our proof, it says we want to prove that the interior angle sum of a triangle is 180 degrees. Where's our triangle? Our triangle is right there. And let's look at our angles. We got an angle, we'll call that one A, B, C, D, and E. So if we're talking about the interior or inside angles summing up to 180, we can rewrite this sentence as angle B plus angle D plus angle E equals 180 degrees. So far, so good. Let's have a look at this next diagram, the next step in our proof. And it talks about alternate angles. So if you remember alternate angles, we've got two parallel lines here, and we know they're the parallel lines because we've got these arrows here. And I'm just going to choose one of the lines crossing, which is a transversal. We're going to do that one in purple. We call that a transversal. Okay, so it says here, alternate angles are, and we should remember that alternate angles are equal, because that is something we know. So remember we said we want to find something we know plus something we know, might be a few more somethings we know, and they will prove something new. So having a look at this diagram, we can see using the purple transversal or the two green parallel lines that this angle C is exactly the same as E. So we don't have to call E E anymore, we can just call it C. So thus angle E equals angle C. So we can just put that down there as C now on our diagram. Now we're on to stage 3 of our proof. And again, it's talking about alternate angles. So let's redraw our parallel lines, put the arrows on there. That tells us they are parallel. Now last time we talked about this purple transversal, but there's another transversal over here. This is the gold one. So that's a transversal. That's just a line crossing two parallel lines. Okay, just to remind ourselves, we've got A, B, C, D, but remember this one is now called C because it's the same size from last time. And we're going to say alternate angles are equal. But instead of looking at the purple ones, we're going to look at the golden ones. So this is another something we know. We already knew that from last time. And so if we look at the golden ones, we'll highlight those in gold. We've got A and D. So thus, or therefore, or whatever way you want to put it, we can say angle D equals angle A. So we can cross off the D and say it's an A. Really good there. Okay, let's look at our final stage of our proof. And it says straight angles are 180 degrees. We should know that, yes? Now, let's have a look at that. That's another something we know that we're adding to our list. And we take a straight line along here. That's one of our straight lines. And we could see before that we had A, B, C. But we also know now that actually the D is now an A and the E is now a C. So thus, it says thus, therefore, however you want to put it. I'm going to take some space down here. Thus, angle A plus angle B plus angle C equals 180 degrees, because we can see there's 180 degrees, which has got angles A, B, and C in it. And we can also see inside the triangle, let's do that in a different color, we got angle B, A, and C. So those three angles are the same as the three blue angles up there. Therefore, thus, the proof is complete. So what did we do? We took something we knew, which was that alternate angles are equal, and something else we knew, which was that straight angles are 180 degrees. And we proved something new, that the interior angles of a triangle sum to 180 degrees. And that's a proof.